Hi, everyone. Good morning, good afternoon, and good evening from wherever you're watching. I'm Comfort Danchavandu, a Nigerian based in Uganda. I'm a PhD student of microbiology in Kampala International University, Western Campus, Bushenyi, Ishaka. I'm so happy and excited to be part of the cohort 15 participants of the PAPERI training on policy, advocacy for genetics and genomics in Africa. My team, which is Team L, is the negative team opposing a motion. I will argue against the use of CRISPR and gene drives to modify insect vectors. I will show that while the technology is promising, it is premature, ethically contentious, and a fraud with ecological and governance risks. I will take you through the introduction, constructive arguments, rebuttals, closing statements, acknowledgement, and references. CRISPR and gene drives are often presented as revolutionary solutions to neglected tropical diseases. But in Africa, limited technological experts, resource constraints, and fragmented regulatory systems make harmonization nearly impossible. Laboratory success does not equal safe field deployment. Major scientific bodies warn that ecological consequences and governance challenges remain poorly understood. We cannot gamble with ecosystems and human lives. In biodiversity-rich African ecosystems, irreversible gene drives raise profound One Health concerns. Once released, they cannot be recalled. Ethical principles demand community engagement, justice, and precaution. Deploying CRISPR-modified vectors now would be reckless and ethically indefensible. Ladies and gentlemen, while CRISPR and gene drives are celebrated as revolutionary tools, we must not be blinded by technological optimism. The promise of eliminating insect vectors sounds appealing, but the risks are profound. In Africa, where ecosystems are rich and governance frameworks are fragile, releasing self-propagating genetic organism changes is not just premature, it is dangerous. My position is clear. The ecological, ethical, and social uncertainties outweigh the potential benefits. I argue for caution, responsibility, and justice before unleashing irreversible technologies. Constructive argument 1. CRISPR and other gene editing technologies are ecologically risky, and the technology is premature. First, the ecological risks are undeniable. Gene drives could spread beyond target species, destabilizing food webs and ecosystems. Imagine the collapse of a mosquito species. Predators, pollinators, and entire ecological chains could be disrupted. Parent and Barrett in 2024 warned that unintended consequences could cascade across ecosystems. We cannot gamble with biodiversity for a solution that may create more problems than it solves. Constructive argument 2. Weak global governance and regulation. First, there is no robust global regulatory framework to manage cross-border release of genetically modified organisms. Gene drives do not respect national boundaries. Once released, they spread across regions. Yet, governance systems remain fragmented and inconsistent. Linhart et al. In 2021 highlight that without established oversight, irreversible impacts are inevitable. Deploying gene drives in such a regulatory vacuum is reckless. Secondly, Africa's fragmented biosafety systems mean that one country's decision could impose irreversible impacts on its neighbors. Therefore, without strong harmonized governance, deploying gene drives is reckless and irresponsible. Constructive argument 3, ethical concerns. The moral status of species and biodiversity. I ask, who are we to decide the fate of an entire species? Eliminating vectors may reduce diseases temporarily, but it violates our ethical obligation to maintain ecological integrity. Biodiversity is not expendable. Therefore, justice and precaution demands that we protect ecosystems, not engineer them into extinction. Constructive argument 4, technical limitations and uncertainties. CRISPR and gene drives are not fail-proof technologies. Target species may evolve resistance, undermining effectiveness. Off-target edits can introduce unintended genetic changes with unknown consequences. Luo in 2024 cautions that these risks are not theoretical. They are real, proven scientific limitations. If the technology itself is unstable, how can we justify releasing it into complex ecosystems? The promise of control is an illusion then. So betting on imperfect science to solve complex public health challenges is an irresponsible act. My proponents claim gene drives will drastically reduce disease burden. Yes, but suppression systems face ecological and evolutionary resistance, limiting long-term effectiveness. They also argue that ethical justification lies in saving lives. Yet, beneficence must be balanced with precaution and justice, especially where communities lack full participatory power. Regulation, they say, can manage risks, but gene drives challenge existing paradigms because they are transboundary and persistent. Current frameworks are just inadequate. Policy and equity concerns, the African experience. Policy and equity are central in CRISPR and gene editing technologies, especially for Africa. Now, I ask, who decides where and when to release gene drives? Will affected communities genuinely participate? Evidence shows informed consent at population level is nearly impossible. For example, Burkina Faso's suspension of gene drive mosquito research in 2025 proves that governments themselves recognize the risks. This is not just theory, it is lived experience. Regulatory frameworks, progress and gaps in Africa. Some African countries have begun developing genome editing regulations, but many still lack comprehensive biosafety laws. This patchwork approach cannot ensure consistent oversight. Stakeholders emphasize that decisions must be context-specific, not one-size-fits-it-all. Without strong governance, deploying gene drives is irresponsible. In conclusion, CRISPR and gene drives are powerful technologies, but their use in modifying insect vectors for NTD control is premature. The ecological, ethical, and governance risks outweigh the potential benefits. We must prioritize precaution, justice, and community voices before considering such irreversible interventions. One Health demands the preservation of the ecosystem with integrity. Let us stop predator decline, pollination loss, niche displacement, and nutrient cycle degradation. Regarding the health of the planet, let us not release these GMOs into the environment when they cannot be recalled. Let us not treat the biosphere as instruments of human utility, undermining the integrity of biodiversity. Humans should remember that insects cross borders, so making release in one nation is a global risk, and we have no global governance over their movements. I hope by these arguments, I have not confused you, but convinced you that while the technology is promising, it is premature, ethically contentious, and fraught with ecological and governance risks. Therefore, CRISPR and other gene editing technologies should not be used to modify the genes of vectors in order to control the NTDs. Thank you for listening. I wish to acknowledge the Pan-African PGS Education and Research Initiative for providing the platform to engage in this critical debate. I thank our instructors, colleagues, and fellow participants for their insights and constructive dialogue. Finally, I recognize the communities most affected by neglected tropical diseases, whose voices and experiences must remain central in shaping ethical and responsible policies for the future. These are my references.